Hi everyone, in this video we're going to talk about the log properties. Alright, there are three properties here of logarithms. Log of a times b equals log a plus log b. Log of a divided b equals log of a minus log of b. And c times log a equals log of a to the c power. And with these properties, the bases would remain consistent. What I mean is, if that's a base of 10, then this would have to be a base of 10, and this would have to be a base of 10. Okay? So I'm going to start out with an example. Let's say we have the expression log base 5 of 25 over the square root of x plus 1. And we desire to expand this expression, all right, into more logarithms. How can we do that? Well, notice in property 2, right, this quotient here, we can use property 2. So I can write this as log base 5 of 25 minus log of the square root of x plus 1. Yeah, we expanded it. And we can touch this up a little bit. First of all, log base 5 of 25, all right? This is a value, all right? 5 to some power in math is 25. 5 to the second power is 25. So this is a 2. And over here, the square root of x plus 1. I can rewrite that as x plus 1 to the 1/2 power. Okay? Yeah, square root of x plus 1 can be written in exponential notation as x plus 1 to the 1/2. And according to property 3, everyone, I can just take this exponent and scoot it to the front. Yeah, take this half and just put it right there. So I can write this entire expression right here as 2 minus 1/2 log of x plus 1. Okay? So, let's do another example. Let's do another example where we have to expand the logarithmic expression. How about, let's see, log of x to the 3rd power times the square root of y all over z to the 4th power. Let's expand this log expression. All right, we notice the quotient, so we can use property 2. Rewrite this as log of x cubed square root of y minus log of z to the 4th power. But are we done? What I mean is, can we expand this further? Surely, right here. Notice it's x cubed times the square root of y. We can use property 1. We can rewrite this as log of x cubed plus the log of the square root of y. And I'll rewrite this, log of z to the 4th. And we've expanded this. And what else can we do? Well, for this third property, I can move that 3 to the front. I can move this square root, which square root of y is y to the 1/2, correct? And I can move that 4 to the front. So I can rewrite this as 3 log x plus, remember that's y to the 1/2 power, 1/2 log of y minus 4 log of z. Okay? Now let's go in reverse. What if I gave you something expanded already, and I want you to condense it into one log? Alright? How about I use natural log? The natural log of, let's see, 5 natural log of a plus 1/2 natural log of b minus 4 natural log of c. So we've got 5 ln of a plus 1/2 natural log of b minus 4 natural log of c. Can we take this expression and condense it into one log? Well, the first step is, everyone. In order to use these two properties, there can't be anything in front of that L of the log, all right? So to do this, if you're condensing this, the first thing is you need to move this by property 3. Scoot that right there. Take this, scoot that right there. So let's do that. I'm going to rewrite this. This is natural log of a to the 5th plus natural log of b to the 1/2 power minus natural log of c to the 4th power. So we have to do that, so if we want to use these two properties to condense it, there's nothing in front of those logs, there's no coefficient there. Alright, what can we do with these two? Use property 1. That's the natural log of a to the 5th, b to the 1/2. We got this minus natural log of c to the 4th. Can we make this one log? Check that out. Check that out. Surely. I'll just write natural log, put a big parentheses, and put this over that. A to the 5th power, b to the 1/2 power, all over c to the 4th power. We have now condensed it into one logarithm. And surely, b to the 1/2 power, can we rewrite that as the square root of b? So I'm going to write this again. I can also write this as natural log of a to the 5th square root of b all over c to the 4th. Okay? And last thing before we go. We've been doing all this stuff, and it may seem silly, but these properties are really important. Why should you take calculus? You'll be working a problem, take you a few minutes, and perhaps you'll get this answer. Let's say you got the answer, natural log of 1/2. And you look in the back of the book to check the answer, and you see that the answer is the natural log of 2. Okay? A student who's not familiar with these properties may be stumped and think they did the problem incorrectly. But in fact, everyone, these are equivalent. These are the same values. We can tell by using these properties. Check this out. See this right here? Isn't this the natural log of 1 minus the natural log of 2? And the natural log of 1 is 0. So 0 minus ln of 2. This is negative ln of 2. These are equivalent. These are the same. So knowing these properties, all right, very, very important. That's it.